In this example, let's solve the given equation by graphing. The given equation is 3x minus 5 equals 1. Yes, I know you could solve this by hand easily, maybe even in your head. You could just add 5, get 3x equals 6, divide by 3, get x equals 2. But that's not the point of this example. The point of this example is to show you a very powerful method for solving equations when you can't actually solve them by hand. We're just starting on one that's easy to work with. But the idea is later on in the future you can use this method on more complicated equations. So what do? How do we solve it by hand? Well, we create two different functions essentially, two different equations. We think of this guy, the left-hand side, as y, or I'm going to call it y subscript 1. And we think of the right-hand side as y as well. I'll call it y subscript 2. And the idea is we graph both of those equations separately. y1 equals 3x minus 5, and y2 equals 1. The point where the two graphs cross is called the intersection point. And the first, as you'll see, the first coordinate of that intersection point will be the solution to our equation. And I'll say more about that in a minute, but let's go ahead and graph these guys. Okay, this is more practice with graphing. You know that y1, or just y equals 3x minus 5. A good way to graph that is the shortcut method. Let's use graph paper here. You can Google image graph paper, print it up, and you want to use it anytime you have to be precise with your graphs. Okay, so the shortcut then, let's go, the y-intercept is 0, negative 5. 1, 2, 3, 4, negative 5. And the slope is 3 over 1. So we can go up 3 over 1. 1, 2, 3 over 1. We could go up 3 over 1 again, although we don't have to. Just connect the dots. 1, 2, 3 over 1. Get out a ruler. I'm going to get my draw tool here and connect the dots. Here I've got to be a bit more careful. I can't just make the dot bigger like I have in the past. If I don't make it through it, I need to be a bit more precise. There we go. That's the first line, y equals 3x minus 5. The second line, y equals 1. Oh, we know that that's a horizontal line going through 1 on the y-axis. So let me graph that. Okay, so the point where they cross, this point right here, is called the intersection point, and it sure looks like it has coordinates 2, 1. And my claim is that then the first coordinate of the intersection point is the solution to the original equation we're trying to solve. So x is going to equal 2. And you can check it, of course. You plug 2 in here for x. 3 times 2 is 6 minus 5 is equal to 1. So you know for sure it works. Now, why does it work? Well, think about it. The left-hand side of the original equation is 3x minus 5. If you plug in 2, that produces a height value of 1. And of course, any point you plug in to the second equation, y2, or just y equals 1, any x value you plug in there doesn't matter because there's no x to plug into. So you could think of plugging in anything you want, 2 or anything you want. Any x value you plug in produces a height value of 1. And so the input of 2 on either side produces the same output value. Therefore, 2 has to be the solution. Now, the reason this method is so powerful is you can use then computers, or in this case a calculator, to solve equations that you might not, other harder equations that you might not be able to solve by hand. So on the TI-84 or 83 plus, go to y equals, and let's solve this on the graphing calculator. Let me get a bigger screen here that you can see. There we go. Let's type in, and this is why I use the subscripts y1 and y2, because that's what the calculator uses. We'll type in under y equals, hit y equals on the upper left-hand button, and then type in 3x minus 5. 3 The X button is right here, -5. Go down, arrow down to Y2 and type in 1. Go to a standard screen, zoom number 6. And we can see it graph both equations. And we can even make it look for the intersection point. If you go to second function, the trace button right here, go over to number 5, or just you could go down to number 5 or just press 5 on your keypad and it will look for the intersection point. So sometimes you need to get the cursor close to where the intersection point is if you have more complicated curves. Here it really doesn't matter. It prompts you for a first curve, press enter. It prompts you for a second curve, press enter. It prompts you for a guess. As long as your cursor is close to the point of intersection, just press enter on guess. And then it gives you, of course, the intersection point 2, 1. And x equals 2 then is the solution to the original equation. One other thing. I want to show you a free online grapher if you don't have a graphing calculator. Let me move it down just a little bit. It's called Desmos. Just Google desmos.com. Launch the grapher, and if you go to the left-hand part, you can input your what we called y1, 3x minus 5. And you can see the line plotted there in red. Put it in projection mode so it's a little more bold. Then go back over to where you inputted the first equation and type in y equals 1. And you can see that's in blue. It's just a coincidence that it used the same color as I did. It was just an accident. And then it actually gives you the intersection point automatically. So x equals 2 again is your solution. So very powerful and useful online grapher, desmos.com. It's free. So use it if you, and just go and play with it if you want some practice with technology.